Hey you guys, it's your soft-spoken scientist, and I'm back with part 2 of this very long yet interesting topic, okay? So let's pick up where we left off. So here we have delta H equals 60 kilojoules per mole. Delta S, 150 joules for moles of Kelvin. At what temperature does the reaction become spontaneous? Okay, so let's talk about it. So we know the formula delta G equals delta H minus T delta S, right? We are solving for the temperature threshold, meaning the point where it just becomes spontaneous. And at the threshold, we know delta G equals 0. So 0 equals delta H minus TOS, as I always like to call it. So how did minus T the alpha S, how do we know we have to move to the other side for temperature? Well, it's in the question, at what temperature? So we want temperature to be isolated, and we got to find out what it is. So what I do on one side, I do to the other. I'm going to add TOS on both sides. And when I do that, I'm going to get T delta S equals delta H. And then I'm going to divide both sides by delta S, because I want to know what T is, not T delta S. So my new formula is T equals delta H all over delta S, okay? So this is the formula I got to use. So I'm going to say temperature, and just plug it in at this point, right? Temperature is going to be delta H, but divide by delta S. I'm going to convert delta S into kilojoules. So we have 150 joules. You divide by 1,000, you get 0.150 kilojoules per moles of Kelvin. And if you watch my first video, you would know how, but I'll just write it out right now. You know 1,000 joules are in 1 kilojoule. Cancel out the J's. You get left with your only unit, and then that would be 0.150. Or you could say 0.150, either one. So now you have 60 divided by 0.150. So it becomes spontaneous when temperature is greater than 400 Kelvin. So the threshold T equals 400 Kelvin. It has to be greater than 400. It becomes spontaneous when T is greater than 400. But the threshold T, again, is 400 Kelvin. Bam, one answer. And it's spontaneous, we could say, for T being greater than 400 Kelvin. Problem 7. We have delta H given, delta S given, and they said at what temperature does the reaction stop being spontaneous? Same idea. You have negative 75 joules. You're going to divide by 1,000 joules for every 1 kilojoule. And you're going to get negative 0.075 kilojoules for moles of Kelvin. You're going to set G equal to 0 because they're asking about temperature again. And you're going to say negative, and you already know the formula, delta G equals delta H minus TOS. And then you're going to say, okay, I have negative 25 minus a temperature that's unknown. And you have delta S, which is negative 0.075, right? And because they're given to us, I'm not going to move anything to the side right now. I'm going to combine my like terms. All right, well, I'm going to combine some things. So I have 0 equals negative 25. And I see a plus. You know how I see a plus? Because I see this negative 0.075 being multiplied to this negative T. I have two negatives. Bam. And bam. When I have two negatives multiplied, that makes a positive. That's what you see right there in yellow. So negative 25 plus 0.075 T. And this is my formula, right? So I'm going to add 25 on both sides, because what I do on one side, I have to do to the other. I have 25 equals 0.075 T. I could have minus 0.075 T on both sides. I could have done that too. Doesn't matter. And then I'm going to divide both sides by 0.075. You may be saying, Vincent, why? Well, how am I going to get to T? But I don't want to know what 0.075 T is. I want to know what T is. So that's how you do that. And then when you do that, you're going to say, oh, wow, T equals 333.3 Kelvin. This reaction is spontaneous at low temperature, but stops being spontaneous after that threshold. So threshold T is about 333 Kelvin. Reaction is spontaneous. 4T is less than 333 Kelvin. All right. Last but not least, and then you're off the hook. Okay, I promise. You have delta H is less than negative 10 kilojoules per mole. Delta S is greater than 40 joules per mole Kelvin. Temperature is 25 degrees Celsius. This is I literally gave you that hint. Temperature is 25 degrees Celsius. Find delta G and determine spontaneity. Okay? So here's the deal. This one is a trap. Temperature is in Celsius. I need it in Kelvin. So temperature, so I should, yeah. I want you to take, for temperature, you know it's 25 degrees Celsius. 25 degrees Celsius plus 273 is 298 Kelvin. And you see delta S is in joules, but I want to convert it into kilojoules. They usually give it to you in joules, but you got to convert. So 40 joules per moles of Kelvin. There's 1,000 joules in 1 kilojoule. So joules cancels out. You can do you can write it out like that and then just cancel. Yep. And then you're going to get 0.040 joules for all the moles of Kelvin, right? Now, delta G equals negative 10 minus 298. Because you guys know the formula. It's delta G equals delta H minus TOS. So 298 was the temperature, minus is between them. Delta H is literally negative 10. It's right there, okay. Now we have delta S, which we just wrote to be 0.040. You're gonna multiply this side. You're gonna get a positive number, and then you're gonna put that negative right there. So you're gonna get delta G equals negative 10 minus 11.92. And then it's going to be negative 21.92 kilojoules per mole, right? And we know what a delta G being negative means. We all know that's a spontaneous, right? So it's spontaneous. That's your answer. And then this is your other answer. Delta G equals negative 21.92 kilojoules per mole. All right, that's it. If you've mastered these 8 problems, you officially know Gibbs free energy and spontaneity better than most people taking general chemistry. If you guys would like, I can do way more harder problems, but I think this is a good start for you guys. I want to thank you guys for watching. Thank you so much for subscribing. I notice those little things. Please, please, please like and subscribe even more. Please, I love when you guys do that. It's great to have the privilege to be doing this. So again, thank you for watching. Comment below and keep striving for the stars.